Hi, I'm Tara McKinnon. I'm a Geographic Information Science and Technology Master's student at Georgia Tech. And I'm going to be talking today about my project, which I submitted an abstract for through Hexagon's Geospatial Education Contest, and I received an honorable mention, which allowed me to go and present my project at Hexagon Live. So the project I'm going to be talking about today is a land cover classification in Georgia using the NLCD tool in ERDAS Imagine. And I've actually been working on this project as part of my research assistantship at the Center for Spatial Planning, Analytics, and Visualization at Georgia Tech. So I'll go over the background of the project a little bit, the study area, and the National Land Cover Dataset. I'll talk about our study objectives, some of the methodology we've worked on, the preliminary results we've received, and kind of our next steps going forward with the project. So the project is taking place in Georgia, southern state in the U.S., the 9th most populous state, and the population more than doubled between 1970 and 2010 from 4.7 million to 9.6 million people, which is a greater population growth over that period than the U.S. on average attained. And much of that population change is due to the rapid growth of Metro Atlanta region over the last few years. So Metro Atlanta now is at a population of almost 6 million. So in comparison to Georgia's whole, that's a very large percentage of the population. So obviously there's a fair amount of development going on that accompanies that population change. But in addition to development, land cover in Georgia has a lot of agricultural land. It's the 15th state in the U.S. for income generated by farming. And in terms of natural vegetation, there's a large amount of forested area, some longleaf pine savannas in the southern part of the state, as well as a lot of wetlands. The National Land Cover Database provides land cover products for the United States. And right now, there are products available for 1992, 2001, 2006, and 2011. And in May, they actually just published new products for 2001 to 2016, increasing the time intervals available there. But all of the classification products are based on 30-meter Landsat imagery, and they cover 21 land cover classes. So our objective with this study is to fill in gaps in the land cover record for Georgia. We wanted to create products for decades where Landsat imagery is available, but no published product exists. So this started in the early 1970s when Landsat first launched. Then we wanted to create another project for the early 1980s, and then one for present. And once all of the products are complete, we're planning to conduct a change detection from the earliest date to the most recent date to kind of get a sense of where land cover in Georgia has been so that we can have a better idea of where land cover in Georgia is going. But the focus here is going to be more on the classification process because this project is still in progress and not everything is complete yet. So starting out, I identified appropriate Landsat level 1 scenes. There are 13 in total that cover the state of Georgia. And to get higher quality images, I chose from multi-date images. So the windows were June to October 1972 and 1973 for the first batch, June to October 1981 for the second batch, and June to October 2017 and 2018 for the third batch. And pre-processing pretty much consisted of reprojecting the data and clipping the imagery to the state boundary. So for the classification process, we use the NLCD tool in ERDAS Imagine, which is just a plugin you can download. It's pretty straightforward to use. And that uses a machine learning classifier to classify the input data into an output product, which is a classified version of your imagery. And it uses dependent and independent variables as inputs. So the independent variables are the images you're trying to classify. So each scene was used as an independent variable alongside a texture of that scene and an NDVI on that scene to add a little bit more information to the classification process. And then the dependent variable is a baseline historic classification that exists for the area you're trying to classify. So in our case, we used the NLCD 2011 product because that was the most recent product available at the time we started the classification process. And after all 13 scenes were classified, I mosaicked them together into a single output product for the state of Georgia for 2017 and 2018. So here you can see on the left is the NLCD 2011 product, so that's what we're kind of basing our classification on. And on the right is the output image from 2017 and 2018. So there are a few things you'll notice. There's a fair amount of development right in the center, and you can see the legend on the right as well. So the pink and the red shows developed area, and you can see that's increased in 2017, 2018 in comparison to 2011. And that actually is where Metro Atlanta is, so that result makes a lot of sense. You can also see that there's a bit more speckling in the 2017, 2018 classification. This is the raw output, so that's something we're hoping to address going forward. And there are also a few areas where the classification actually didn't occur because the image quality was low. We ended up masking that and not creating an output for those areas, and that's something we're planning to address in post-classification as well. So these are just some preliminary comparisons from the classification. There's no kind of change detection that's been done on this. But you can see that developed space, medium and high intensity space increased in 2017, 2018 versus the 2011 region, but developed open space and low intensity space decreased, and that there are also across the board decreases in deciduous forest, evergreen forest, woody wetlands, and emergent herbaceous wetlands. So that is kind of the initial trend. It'll be interesting to see if those hold as we kind of go through the post-classification process with that 2017-2018 imagery. So going forward, some post-processing still needs to be done, as I mentioned, on the 2017-2018. I'm hoping that smoothing, trying a couple of different smoothing techniques will improve the speckling we saw in that mosaic output. And then for images where clouds or other poor image quality impacted the classification process, I'm planning to go back and mask and replace those masks with alternate imagery from different dates. So although we use the highest quality imagery available, it's difficult to get high quality imagery within a short time frame for a 13 Landsat scene area. It's challenging, so we're still working on that part a little bit. And then we're going to repeat the classification process for the 70s and 80s imagery and ultimately conduct a change detection to get a sense of how land cover has changed in Georgia over the this almost 50-year time period. And I think that the results are going to be really interesting and really informative, especially as land cover change continues to happen, and especially in the American South. So thank you so much for tuning in. I'd also like to say thanks to Georgia Tech and specifically the Center for Spatial Planning, Analytics, and Visualization, and my supervisor, Tony Giarusso, for helping me get to Hexagon Live, and to the Hexagon Geospatial team as well. Thanks.